Welcome class, myself Professor D. S. Rai, Professor Department of Civil Engineering, BBDA, ITM Lucknow. We are discussing course KCE 076 Urban Transportation Planning. Today lecture is lecture number 22, in which we will discuss modal split part 1. References that I have taken: Chakrabarti, Partho and Das Animes, Principle of Transportation Engineering, Papacosta CS and Predores PD, Transportation Engineering and Planning, Kadiali and Lal, Principle and Practices of Highway Engineering, Naptel and Internet Materials. Contents today we will cover travel mode, factor influencing mode choice, modal classification, type of modal split model, southern Wisconsin model, aggregate modal split model, diversion curve model, TTR, relative travel cost, relative travel services, disaggregate mode choice model, role of choice in generating travel demand, elements of choice decision process, basic step in modeling, concept of utility. So, first we are going to discuss a travel mode. A typical travel situation, a trip maker can make a choice among the several travel modes. So, we can see here the first is personalized mode like car, two-wheeler, bike, etc. The second, shaped public transit mode like bus, train, metro, etc. A mode choice or a model, a split model is concerned with the trip maker's behavior regarding the selection of the travel mode. Factor influencing mode choice. Basically, there are three categories. First is socio-economic characteristic of trip makers, which includes household income, car ownership. Second is characteristic of the trip, in which trip purposes, trip distance, time of the day are included. Now, characteristic of transportation system, in which travel time and comfort and convenience of the are included, family size, age and gender, trip distance, time of the day, travel cost, reliability, comfort and convenience, etc. Factor influencing mode choice includes characteristic of transportation system, that includes travel time, travel cost, reliability and comfort and convenience, etc. Now, come to the modal classification. Based on the type of analysis used, model may be classified as aggregate model represents the average behavior of a group of a traveler instead of a single individual on zone based. Disaggregate model individual choice responses as a function of characteristic of alternative and socio-demographic attributes of each individual. Type of modal split model. According to the position of analysis in relation to the travel forecasting process, modal split model may classified as trip in modal split model, and second is trip interchange modal split model. trip generation model, a split trip distribution model, a trip end type, trip interchange type. So, in this diagram we can see this is the trip generation. So, in a model S split, when model S split after trip generation, model split will come in existence and then trip distribution will come. This will be applicable when the trip is end type. When trip distribution will come before modal split after trip generation, and this will happen when the trip interchange type, means the trip is continuous. So, modal split will come first of the trip distribution when the trip is end type. The type of modal split models used by early researchers may call as a early generation model. This included both trip end modal split model and trip interchange modal split models. The trip end model split models use socio-economic characteristic of the trip maker as the prime determinants. The trip interchange model, a split model, use service characteristic of competing model along with the socio-economic characteristic of the trip maker. So, there is a southern Wisconsin model. Percentage of trip ends likely to use transit services from a zone was related to first trip types, second socio-economic characteristic of trip makers and characteristic of transportation system. The trip were stratified as home based work, home based shopping, home based others and non home based trip. A average number of car per household in a zone was considered as a representation of socio-economic characteristic of trip makers. Effect of transportation system was duly considered in the term of accessibility index of a zone. So, accessibility index is sum over j is equal to 1 to n A j into F I j, where ACCI accessibility index of zone I, A j number of attraction in zone j, F I j travel time factor from zone I to zone j for a particular mode. Now, aggregate model, a split model. Relative transportation services provided by two modes, that is private vehicles and transit, was characterized by accessibility ratio. The accessibility ratio is highway accessibility index divided by transit accessibility index, and example is given here, it has been taken from NAPTEL. So, for 1 is the central point, central business center, second has A2 150, A3 250, A4 100 and A5 200, and here 10 travel time by car, this is the minimum time required by a car from a particular destination to next destination. 15 is the travel time by transit, means bus etc. So, aggregate model split model accessibility index will be equal to sum over j is equal to 1 to n A j into F I j, and that will be equal to sum over j is equal to 1 to A j into T I j to the power minus 2. So, car accessibility index for a zone 1 150 into 15 to the power minus 2 plus 250 into 25 to the power minus 2 plus 100 into 10 to the power minus 2 plus 200 into 20 minus to the power minus 2, and that will come after calculation 2.567. Now, come to the transit accessibility index for zone 1 150 into 220 to the power minus 2, 250 into 30 to the power minus 2 plus 100 into 15 to the power minus 2 and 200 into 25 to the power minus 2, and that will come 1.417. So, accessibility ratio will be 2.567 divided by 1.417, and that will come 1.81. So, diversion curve model, the basic hypothesis underlying this model developed for metropolitan Toronto, Canada was as follow. The total number of people moving between the origin destination pair constitute a travel market, where various modes compete. Competing modes secure position as per their relative competitiveness expressed in terms of relative competitiveness expressed in terms of relative travel time, relative travel cost, relative travel services and economic status of the trip makers. So, come to the TTR, travel time ratio. A relative travel time by competing mode was expressed, travel time ratio TTR will be equal to A plus B plus C plus D plus E divided by F plus G plus H, where A is the time spent in transit vehicles, B transfer time between transit vehicles, C time spent waiting for transit vehicles, D walking time to transit vehicles, E walking time from transit vehicles, F car driving time, G parking delay at destination, H walking time from parking place to the destination. Relative travel cost. Relative travel cost was defined by the ratio of out of pocket travel cost by public transit and the car. So, CR will be equal to I upon j plus k plus 0.51 L into upon m. Here I is equal to transit fare, j is equal to cost of petrol, k is equal to cost of oil, lubricant, etc. L is equal to parking cost at destination, m is the average cost of occupancy. So, now come to the relative travel services. The relative travel services was characterized by the ratio of excess travel time by the transit and the car. The excess travel time was defined as the amount of time spent outside the vehicle during trip. So, service ratio was defined as SR is equal to B plus C plus D plus E divided by G plus H. So, interchange volume from trip distribution was multiplied by appropriate percentage obtained from the diversion curve, developing using this ratio to arrive at the market share of two competing modes of travel. Limitations of this model: the captive and the choice transit rider were not identified and represented separately in this model. For this reason, model failed to reflect adequately the way choice transit rider react to change in transport system characteristics. Data used were all zonally aggregated in nature. Advantage of aggregate models. This aggregate approach explains why an individual makes a particular choice given the circumstances and is better able to reflect the changes in the choice behavior due to change in individual characteristics and attributes of alternatives. Because of this causal nature, they are likely to be more transferable to a different point in time and to a different geographical context, a critical requirement for the prediction. Disaggregate mode choice model, more suited for proactive policy analysis since they are a causal. Less tied to estimation data and more likely to include a range of relevant policy variables. More efficient in terms of model reliability per unit cost of data collection, whereas aggregation leads to considerable loss in variability, thus requiring much more data to obtain same level of model precision. Obtain unbiased parameter estimates if properly specified, unlike aggregate model estimates that are known to be biased. Role of choice in generating travel demand. Travel is the result of choices made by individual. Number 1, for travel to work, whether to use car or take a bus or travel in taxi. Second, individual must also decide when to leave home and which route to use depending on the choice chosen mode. The objective, the model and predict the outcome of choice may be individuals. Elements of choice decision process. Decision makers, the individual, group or institution that has responsibility to make decision at hand. Sorry. Alternatives. Choice is made from a set of available alternatives. Attribute to alternatives. Alternatives are characterized by a set of attribute value. Decisions rule mechanism to process information and evaluate alternatives. So, basic steps in modeling. First step, identify choice of mode and the option travel modes such as car, taxi, bus, etc. available to an individual. Step second, identify variables likely to affect mode choice such as travel time, travel cost, comfort, reliability. Step third, develop a mathematical formula that describe the dependence of choice on the relevant variables. Preferences. An individual choice represents one preference among the available option at the time of making choice under the existing circumstances. For example, a commuter boarded a bus because of money shortage, otherwise he would have boarded a taxi. Modeling and predicting. Choice is equivalent to the modeling and predicting preferences. Preferences among a set of options depends on attribute to option and individuals. Now, come to the concept of utility. Utility function measures a degree of satisfaction that a people derive from their choices. Magnitude of utility depends on characteristic of alternatives and that of the individuals. The utility or disutility function is typically expressed as a linear weighted sum of the independent variables. So, u will be equal to a 0 plus a 1 x 1 plus a 2 x 2 plus and so on a r x r, where u is the utility derived from a choice defined by the magnitude of attributes x in the choice weighted by the model parameters. In a mode choice context, u is disutility and is a negative since independent variables are travel times, out of pocket expenses, etc. Early attempts to describe utility of travel modes calibrated a separate utility function for each mode as a follow. So, it will be u 1 is equal to 6.0 plus 2.3 x 1 plus 3.4 x 2, u 2 is equal to 3.2 plus 3.2 x 1 plus 2.8 x 3, u 3 is equal to 4.1 plus 2.8 x 1 plus 3.1 x. So, these are the variables. Concept of utility. This type of formulation is known as mode specific or choice specific model, because same attributes are assigned different weights for different modes. Variable need not be same in different equations. The hypothesis causes a problem when a new mode is introduced because of lack of data required for calibration of its utility function. So, to resolve this, a new approach is called choice abstract or attribute specific approach was proposed. As per this approach, when making a choice, people perceive goods and services indirectly in terms of their attributes weighted identically across a choice. So, u is equal to 3 plus 2.3 x 1 plus 3.4 x 2 plus 4.5 x 3. So, thank you very much. Thank you.